Page 40.
Module 2.3 Costs. Rationale. The firm employs various combination of inputs to produce outputs. With the input price given, the firm will choose the least cost combination of inputs. Hence, the cost structure of a firm shows the relationship between cost and output. Key concepts: total cost, total fixed cost, total variable cost, average cost, average fixed cost, average variable cost, marginal cost.
2.3.1 Short-run costs. We know that in the short run, factor 2 is fixed at some level, x2 bar, and to produce a certain level of output, we require a certain level of variable factor 1. Therefore, in the short run, a producer has only one option of factor combination, that is, within brackets, x1, x2 bar for a given level of output small q1. Cost functions are different in case of short run and in the long run. We will first discuss about the short run costs. Table 2.2 gives an example of short run costs for a firm. It is in short run because factor 2 is fixed at some level. Table 2.2 Various costs of a firm. This table has 8 columns and 10 rows. The columns are output, TFC, TVC, TC, AFC, AVC, SAC, SMC. In row 1, when the output equals 0, TFC equals 20, TVC equals 0. TC equals 20, there is no AFC, AVC, SAC or SMC. In row 2, when output equals 1, TFC equals 20, TVC equals 10, TC equals 30, AFC equals 20, AVC equals 10, SAC is 30 and SMC is 10. In row 3, when output equals 2, TFC equals 20, TVC equals 18, TC equals 38, AFC equals 10, AVC equals 9, SAC is 19, SMC is 8. In row 4, when output equals 3, TFC equals 20, TVC equals 24, TC equals 44, AFC equals 6.6, AVC equals 8, SAC equals 14.6, SMC is 6. In row 5, when output equals 4, TFC equals 20, TVC equals 29, TC equals 49, AFC equals 5, AVC equals 7.2, SAC equals 12.2 and SMC is 5. In row 6, when the output is 5, TFC equals 20, TVC equals 33, TC equals 53, AFC equals 4, AVC equals 6.6, SAC is 10.6, SMC is 4. In row 7, when output equals 6, TFC equals 20, TVC equals 39, TC equals 59, AFC equals 3.3, AVC equals 6.5, SAC is 9.8, SMC is 6. In row 8, when output equals 7, TFC equals 20, TVC equals 47, TC equals 67, AFC equals 2.8, AVC equals 6.7, SAC is 9.5, SMC is 8. In row 9, when output equals 8, TFC equals 20, TVC equals 57, TC equals 77, AFC equals 2.5, AVC equals 7.1, SAC equals 9.6, SMC equals 10. In the last row, 10, when the output equals 9, TFC equals 20, TVC equals 71, TC equals 91, AFC equals 2.2, AVC equals 7.8, SAC is 10.1, SMC is 12. Please note that the output is measured in physical units while all costs are measured in rupees wherever indicated. Column 1 in table 2.2 gives the amount of output and the rest of the columns give various types of short-run costs. Figure 2.5. Total fixed cost. We have before us a graph with two axes. The x-axis, which is divided into 9 equal parts, represents output. The y-axis, which is divided into segments of 5, indicating 0 to 20, are cost in rupees. The line extending from point 20 on the y-axis parallel to the x-axis represents TFC, which is total fixed cost.
Page 41.
Total fixed cost is that part of the production cost which does not change with the level of output. For example, initial setup cost required before starting any production and salaries of some employees like company accountant and security guard. Since the unit of factors employed is fixed in the short run, thus the cost incurred on them is also fixed and is denoted as TFC, which is shown in the second column of table 2.2. TFC is not dependent upon the level of output. It is fixed at a level of rupees 20 for all output units. TFC is incurred even when production is not taking place. Please note in table 2.2 that TFC is 20 when output is 0. In figure 2.5, TFC curve is represented by a horizontal line.
Figure 2.6. Total variable cost. Here we have a graph with two axes. The x-axis represents output. The y-axis represents cost in rupees. The x-axis has been divided into 9 equal parts. The y-axis has been divided into 7 parts at the interval of 10 each. On this graph, we have the TVC curve, which is in the shape of an inverted S. In addition to the fixed cost, there is a variable cost that changes with the level of output. For example, labor cost and cost of raw material. Thus, the total cost of hiring inputs that vary with the quantity of output produced is the total variable cost. It is denoted by TVC, which is shown in column 3 of table 2.2. As depicted in figure 2.6, if the values of column 3 are plotted against the values of output, then we get a TVC curve. It starts from the origin, since zero output does not cost anything to a variable factor. Moreover, TVC curve has an inverted S shape. The reason for S-shaped TVC curve is the law of variable proportions. TVC is 0 when output is 0, and it rises as the output increases. It means when more of a variable factor is added to the fixed factor, the total production increases at an increasing rate, while the total variable cost increases at a diminishing rate. Beyond the output of 4 units, as more variable factor is added to the fixed factor, total production increases at a diminishing rate, and after reaching its maximum, it begins to fall. This implies a rising TVC curve at an increasing rate. Given a fixed price of labor, this also explains that initially, additional units of output require less additional expenditure on the labor. It means that initially TVC is increasing, but at a decreasing rate. But after some level of use of labor, TVC eventually starts to increase at an increasing rate. This rate of change is the slope of the TVC curve. Thus, an inverted S-shaped TVC curve implies initially declining and eventually increasing slope.
Page 42. Figure 2.7 Total cost. The graph before us has two axes. The x-axis has been divided into 4 segments of quantity 2, and this represents the output. The y-axis represents cost in rupees and has quantities from 0 to 90 at intervals of 10. We have before us 3 graphs. One is a horizontal line which is parallel to the x-axis and starts at point 20 on the y-axis. This dotted line represents TFC. Rising from the origin in the shape of an inverted S is the TVC. Rising from point 20 on the y-axis in the shape of an inverted S is TC. The distance between TC and TVC is constantly 20. The total cost in the short run is denoted by TC and is considered as, within brackets, TVC plus TFC. If you add the fixed cost of rupees 20 to TVC at any level of output, then you get TC. In table 2.2, TC is given in column 4 and is drawn in figure 2.7. TC curve is shaped like TVC curve shifted up vertically by rupees 20. TC is rupees 20 even when output is 0, as the firm incurs a fixed cost, TFC, of rupees 20, which is the vertical distance between TC and TVC curves, as also drawn in figure 2.7.
Figure 2.8 Average Fixed Cost. Here we have a graph with two axes. The x-axis represents output. The y-axis represents cost in rupees. The x-axis has been divided into 9 equal parts. The y-axis has been divided into 4 parts which are at an interval of 5 each. There is a downward sloping curve here which represents AFC. If we distribute the total fixed cost over all the units of output, then we get the average fixed cost. It is calculated as TFC divided by small q and is denoted as AFC. The values calculated for AFC are given in column 5 of table 2.2. It is not defined for 0 level of output. At larger levels of output, cost of the fixed factor gets divided among more units of output and thus share of each one in fixed cost goes down. Hence, AFC curve is falling as also depicted in figure 2.8. The shape so obtained is known as a rectangular hyperbola. AFC curve approaches x-axis as output increases, that is, the fixed cost per unit decreases.
Page 43, figure 2.9, Average Variable Cost. The graph before us has two axes. On the x-axis is plotted the output and there are 9 points equidistant from each other. The y-axis represents cost in rupees and the values are from 0 to 10 at intervals of 2 each. And the U-shaped curve indicates AVC. The TVC divided equally among all units of output is known as average variable cost. It is calculated as TVC divided by small q and is denoted by capital AVC. It is given in column 6 of table 2.2 and is represented by figure 2.9. Note that just like AFC, it is also not defined for 0 level of output since division by 0 is not feasible. The AVC of any level of output falls initially as output increases. It reaches a minimum value of 6.5 rupees per unit of output when the output level is 6 units. AVC starts increasing thereafter as output increases further. AVC curve is U-shaped due to law of variable proportions.
Figure 2.10 Short Run Average Cost. Here we have a graph with two axes. The x-axis represents output. The y-axis represents cost in rupees. There are three curves here which are in the shape of U. The first curve, which is closest to the y-axis, is the ABC curve. The second curve is the AFC curve. And the third curve is the SAC curve. Note that the ABC curve and AFC curve intersect each other. The sum of short run AVC and the short run AFC is known as the short run average cost or the average total cost. It is denoted by SAC or the ATC and is calculated either as TC by small q or as total of AVC plus AFC for any level of output. The column 7 in table 2.2 gives you the SAC and the curve is drawn in figure 2.10. It is represented as a U-shaped curve. But SAC lies above AVC at all levels of output, since we get SAC after adding a positive AFC to AVC. However, the vertical gap between SAC and AVC is not constant, but instead goes on decreasing at higher output levels. This is because the vertical distance is AFC, which is declining as output rises.
Page 44. Figure 2.11 Short Run Marginal Cost. We have before us a graph with two axes. The x-axis, plotted from 0 to 8, represents output. The intervals equal 2. The y-axis, representing cost in rupees, is represented by values 0 to 12 with intervals equal to 2. Here we can see a slightly U-shaped curve, and that here we find a slightly U-shaped curve indicating SMC, and it reaches a minimum point when x equals 5 and y equals 4. The addition to total variable cost or total cost due to production of an extra unit of output is called the marginal cost. It is denoted by SMC for the short run. SMC of say Q2th unit of output is equal to open square bracket TC of Q2 units minus TC of within brackets Q2 minus 1 units close square bracket, which must be equal to open square bracket TVC of Q2 units minus TVC of within brackets Q2 minus 1 units close square bracket. It is not defined at 0 level of output. When we plot the values of marginal cost from column 8 of table 2.2 against the units of output, then we get a U-shaped SMC curve as in figure 2.11. SMC falls as output increases, reaches a minimum level of rupees 4 for the 5th unit of output, and then rises for higher level of output. SMC is U-shaped because of increasing and then decreasing marginal returns.
2.3.2 Relationship between the average and marginal cost curves. As represented in figure 2.12, AFC declines with the increase in output. AVC and ATC curves first fall and then rise with the increase in output. MC falls initially and then rises, intersecting the ATC and AVC curves at their minimum points. Figure 2.12 Short Run Average and Marginal Cost Curves. Here we have a graph with two axes. The x-axis represents output and the y-axis represents cost in rupees. Represented here are three curves in the shape of U. The first curve, which is closest to the y-axis, represents SMC. The second curve represents AVC. The third curve represents SAC. Note that the SMC curve intersects the AVC curve at the point N. It also intersects the SAC curve at the point M.
Page 45.
SAC and SMC curves are drawn together in figure 2.12. Notice that at smaller levels of output, SMC is less than SAC, and for larger levels of output, SMC is more than SAC. The U-shaped SAC curve attains its minimum value at point M. At this point, SMC curve intersects with the SAC curve, implying that the two costs are equal at this point. At the point of its minimum value, note that the slope of SAC curve is 0. Similarly, AVC attains its minimum value at point N, where AVC is equal to SMC, as the SMC curve intersects the AVC curve at this point.
2.3.3 Long Run Costs. In the long run, a producer has the option to choose from any of the various factor combinations. To produce Q1, she can choose the cheapest factor combination, which might be different from a short-run combination, within brackets x1, x2 bar. The cost in the long run will, therefore, be less than or equal to the cost in the short run, as the factor combination can be changed with ease in case of long run. Suppose the relative prices of factors change. Then, cheaper factors can be easily substituted by the expensive factors in the long run. Thus, the factor combination can be changed in order to cut down the cost of production. A producer knows the minimum cost of production for each level of output. Hence, the long-run total cost is the minimum cost of producing at each level of output in the long run, since the firm has access to adjust all its inputs. Average cost and marginal cost in the long run are termed as the long-run average cost, within brackets, in capitals, LRAC, and the long-run marginal cost, within brackets, capital letters, LRMC, respectively. Figure 2.13 Long-run total cost. We have thus a graph which has the x and y axis. The x-axis represents output and the y-axis represents cost in rupees. We have an inverted S graph representing LRTC. In figure 2.13, long-run total cost curve in rupees has been placed on the y-axis and the amount of output in physical units has been placed on the x-axis. In the long run, none of the factors is fixed. Since all the factors are variable, the long-run total cost, LRTC, curve passes through the origin, unlike the short-run total cost curve, refer to figure 2.7 for it. When the output is 0, then there is no cost in the long run, as all the unused fixed factors of the short run are sold. LRTC has an inverted S shape. It is generally observed that a producer enjoys increasing returns to scale, capital IRS, at a lower level of output, followed by constant returns to scale, capital CRS, at a medium level of output, and then by decreasing returns to scale, capital DRS, at a higher level of output.
Page 46. 1.
Increasing returns to scale, IRS, implies that the output increases more than the proportional increase in all inputs. In this range of output, the cost of production is decreasing. Hence, LRAC falls as output increases. This property is also known as economies of scale. Economies of scale arise when the laborers get specialized in their respective production activities, thereby producing more output in less time. As a result, the cost of production is decreased.
2.
Constant returns to scale, that is CRS, implies that output increases in the same proportion as increase in all inputs. In this range of output, the cost of production remains constant. Thus, LRAC does not change as output increases.
3.
Decreasing returns to scale, that is DRS, implies that output increases less than the proportional increase in all inputs. In this range of output, the cost of production is increasing. Therefore, LRAC rises as output increases. This property is also known as diseconomies of scale. Diseconomies of scale occur when there are coordination problems among the laborers, which generally happens in case of large organizations. This lowers the productivity and increases the cost of production.
Figure 2.14 Long Run Costs. Here we have a graph with two axes. The x-axis represents output. The y-axis represents cost in rupees. There are two curves here. The first curve, which is in the shape of a U, represents LRMC. The second curve, which is also in the shape of a U, represents LRAC. Both these curves intersect at point M and output Q1. LRAC has a U shape due to IRS at a lower level of output, followed eventually by CRS, where LRMC is equal to LRAC, and then further by DRS. LRMC is also U-shaped. Follow figure 2.14. LRAC is falling at the output level where LRMC is less than LRAC. Then LRAC reaches its minimum at point M, where LRMC is equal to LRAC. At this point, LRMC curve cuts the LRAC curve from below. Further, LRAC rises at the output level where LRMC is more than LRAC.
Page 47. Figure 2.15 Average total cost curve in the long run. We have with us a graph where the x-axis represents output. On it are plotted 3 points indicating 3 quantities, Q1, Q2, Q3. The y-axis represents the average total cost in rupees. On it are indicated 2 values, ATC and ATC1. We have a large U-shaped curve which represents ATC in the long run. This is the largest U-shaped curve on the graph. Points of minimum value, which are Q1 ATC1, are the intersection point between ATC in long run and the U-shaped curve SATC of small factory. Points Q2 ATC, which is the point of intersection of ATC in long run and SATC of medium factory. The points of intersection Q3 ATC1, which is ATC in long run and the SATC of large factory. There is another crucial difference between the short run and long run cost curves. The long run cost curves are flatter as compared to the short run curves because change in cost as output increases is slower in the long run than in the short run. This is because as the producer changes output, long run allows her to use a cheaper factor combination and therefore produce at a lower cost than in the short run. However, this process takes time for the change to become noticeable, and so it is a slower process. As depicted in figure 2.15, the long run average total cost curve envelopes all the short run average total cost curves of a firm.
Test your understanding. The table here gives the total cost or TC of a firm. Find TFC, TVC, AFC, AVC, SAC and SMC of the firm. In the table, we have 8 columns and 7 rows. The first column represents output, the second column represents TC, the third column represents TFC, the fourth column represents TVC, the fifth column represents AFC, the sixth column represents AVC, the seventh column represents SAC, the eighth column represents SMC. The values in first row are: when the output is 0 and TC is 10, then you have to fill in the other values. The values in second row are: the output is 1, the TC is 30, and you have to fill in the other values. In the third row, the output is 2, TC is 45, you have to fill in the other values. In the fourth row, the output is 3, TC is 55, you have to fill in the other values. In the fifth row, the output is 4, TC is 70, you have to fill in the other values. In the sixth row, the output is 5, TC is 90, you have to fill in the other values. Lastly, in the seventh row, the output is 6, TC is 120, and you have to fill in the other values.